Hello, beautiful people. Welcome to 8.1 Model, Inverse, and Direct Variation. Direct variation you've seen before. That is given by the equation y equals k times x, where k is your constant of variation, and we read that as y varies directly with x. Y varies directly with x. However, two variables, x and y, will show inverse variation if, and only if, y is equal to k divided by x instead. So k divided by x. And we will read that as y varies inversely with x. So these are the two equations you're going to want to memorize for this lesson. Kx, you know, k divided by x for the inverse, which kind of makes sense because multiplication inverse would be division by x. Determine if x and y vary directly, inversely, or neither. So in order to do these, I like to get the y by itself so that I can see exactly what's happening. So I'm going to divide both sides by x, and I get y is equal to 0.48 divided by x. If x is in the denominator, if it's dividing, then I'm going to go ahead and call this one inverse variation. And my constant of variation would be 0.48. Not that they asked, a little extra for you. Y is not alone. This would look like, hey, there's a fraction. Maybe it's inverse. But I'm going to get y by itself by multiplying both sides by 1.5. So that these cancel. And I have 1.5x equals y. I know what you're thinking. Direct variation. And I would agree because it's just kx. My constant of variation for this one is 1.5. Love it? I knew that you would. Now, example 2, x and y vary inversely. For me, that triggers y equals k divided by x. And y equals 6 when x equals 1.5. Part A, write an equation that relates x and y. Well, I know my equation, y equals k over x. I need the k in order to write the equation that they're asking me for. So I'm going to use the given information. Sorry, that's crickets, probably bothering you. 6 is my y equals k divided by x, which is 1.5. I'm going to multiply both sides by 1.5 so that they cancel out here. And I find that k is equal to 1.5 times 6 is 9. Which is great, but that's not my answer. They wanted me to write an equation that relates x and y. So y is equal to 9 divided by x. And there you go. Next part, for part B, they would like for me to find the value of y given the x. So a fraction over a fraction could be mad confusing. Clearly, I can't even say it. But please remember that the division fraction bar the fraction bar means division. So this is like saying 9 divided by 4/3. So I'm going to multiply by the reciprocal. And nothing cancels out as I might have anticipated it would. So I'm going to multiply straight across and get 27/4. Improper fractions are absolutely fine for us. Like it? I knew that you would. Okay, let's check out example 3 on the back side of your paper, possibly, depending on how it was photocopied. And determine whether x and y show direct variation, inverse variation, or neither. So one thing I like to do for these, kind of helpful, direct variation. I know that y is equal to kx. And for these problems, when I'm giving the xy table, I like to just figure out what's happening for the k. Like what I need to do in x and y, and is there a constant number k? So I'm going to divide both sides by x, and I find that k is equal to y divided by x. So if that's constantly for each one, so k equals y over x, I'm going to divide, and I get 9/2, which is equal to 4.5, by the way. For this one, the y is 4.5 divided by 4. Is that 4.5? Not at all. So it's not going to be direct variation. If it was the same ratio every single time, then I would automatically and quickly say, yeah, that's going to be direct variation. But that did not work out for me. So let's check out inverse variation. You know, generally it's y equals k divided by x. Well, let's multiply by x, and I find that k is equal to yx. So if I multiply these numbers and get the same thing every single time, then that would be a representation of inverse variation. 2 times 9 is 18. What a coincidence. 4 times 4.5 is also 18. 6 times 3, 18. Looks like we have a winner. 8 times 2.25 is 18, and this is 18 as well. So my constant of variation is 18 because it was constantly 18, and my equation for inverse variation is y equals k inverse divided by x. Love it. So something new for you. Joint variation. Sounds interesting. Joint variation occurs when a quantity varies directly as the product of two or more other quantities. So we would say this as z equals k, same constant of variation that we're dealing with here, times xy. Z varies jointly with xy. All right, let's do some of these just for the fun of it. Letter A, y varies inversely with z cubed. Y varies, so y equals, that's how I'm interpreting this, inversely. So I know it's going to be k because there's variation, but if it says inversely, it's going to go on the bottom, z cubed. So the next one, z varies. Now it says jointly. So that's just going to be x squared and y. I was anticipating a fraction, that's why it looks like that. Y varies inversely. That means divided by z and x. Y, this is me interpreting, equals k. Now directly with x, so k times x, and inversely with z squared. So that will go on the bottom. A little more interpretation. If you want, go ahead, press pause right now and see if you match me. Varies directly with x squared and inversely with z. There you go. All right, last one. Thanks for hanging in there with me. The variables, the variable, I said variables. The variable z varies, interpret that, jointly with x and the square of y. What's the square of y? Square of y is y squared. Great. When x equals 10 and y equals 9 and z equals 135. They've given me a lot of information here just for me to find out what the k is. I have every variable but the k. I can solve that. So I'm going to, in order to do what they want me to do, write an equation like this, except finding the k. That's what I'm seeking. Let's plug in everything you know. So instead of z, 135 equals k. We don't know what that, we don't know what that is just yet, but I do know what the x is, which is 10, and I do know what the y is, which is 9. And I'm going to leave that squared because it said squared. So 135 is equal to 81 times 10, 810k, divided by 810. So the k is equal to, if I divide both sides by 135, I get 1 over 6. I did it ahead of time, guys. I'm not even going to front. So then I'm going to find my equation, and I'm basically going to rewrite this whole thing, except instead of the k, I'm going to write 1 over 6. Everything else, the x, and the y squared will stay the same. Cool. Next thing, find z when x equals 45 and when y equals 8. And you can do this on your calculator, or you can just multiply it out, whichever way you want, but you should get 480. And that concludes our lesson on direct variation, which is also not the title of this, but that concludes our lesson on direct and inverse, but also joint variation. So thank you so much for joining us, and have a great day.